Oh, wow. Yeah, it's right in my.
Any question before we start? So let's continue on um, finding extreme values for crank rocket mechanism for transmission angle. Transmission angle is the angle between output link and the coupler. So what we are looking for when this crank rocket mechanism is running, it's completing 360 degrees. This angle is varying over the time. So we would like to know at which input angle, at which theta, we are gonna get the maximum as a minimum of transmission angle. So what we did on Wednesday class, I wrote the cosine rule for this triangle as well as this triangle. I wrote the cosine rule for h. So h squared in this triangle, it's given here. It's given here, and cosine rule for this one, you can see right there. So and we solve for cosine of mu, and we got this function. Cosine of mu as a function of b squared plus c squared minus a squared minus b squared divided by 2bc plus 2ab cosine of theta divided by 2bc. So it's showing me how the transmission angle in crank rocket is varying with theta. So when we are going to find the extreme value of a function, what we are doing, we differentiate that function and set it equals to 0 derivative, and we find the optimum point. This is what I'm going to do here. I differentiate both sides. Here, the derivative of if I want to differentiate that, I will get negative sine of mu d mu. Derivative of cosine is going to be negative sine of mu times derivative du. So this part is constant. If I differentiate that, it's going to be 0. This part, this is the coefficient to cancel out AD divided by BC. Derivative of cosine of theta is going to be negative sine of theta d theta. Then I simplify this to get d mu over d theta. I divide both sides by d theta. I will get, I can cancel out these two negative. A, D, B, C, sine of theta, sine of mu. So left hand side is telling me how the transmission angle is varying with changing theta. Right hand side is a function of theta and mu. So if I want to get the extreme value for the mu, I set it equals to 0. So this cannot be 0. The only way that I can make this equation equals to 0, theta should be either 0 or 180. Okay. So it means my crank rocket mechanism, it's going to have transmission angle at extreme position when theta is 0 at this position. This is going to be one of the extreme value. And when it goes all the way to 180 degrees, this transmission angle is going to be another extreme value. One of them is minimum. This you can see this when theta is at 0, I will get the minimum value of the transmission angle. When it goes to 180, the maximum value of the mu can be obtained. So what I'm gonna do, I'm gonna find the value of the mu at theta equals to 0 and at theta equals to 180. So here I'm just plugging theta equals to 0 at theta equals to 0. Cosine of 0 is 1. So what I will get is cosine of mu would be two BC after b squared c squared minus a squared minus d squared plus 2ab. B squared plus c squared minus a squared minus d squared plus 2ab. Or if I want to say it again.
If you wanted to rewrite it.
If I
Wanted to rewrite it. No, just no. Okay.
I'm just plugged in theta equals to 0, got cosine of 0 equals to 1. So these three terms I can write in this. A minus d, the summation squared, it's going to be a squared plus d squared minus 2ab. So I have negative here, I will get these three terms. So mean is going to be cosine inverse of this side, cosine inverse of b squared plus c squared minus a minus b squared to bc. So if you want to know what would be the transmission angle, the minimum value of the transmission angle, you can just plug in the length of b, length of c, and a, calculate this value, and then do the cosine inverse and get the mu mean. If I ask you at which input angle I'm going to get this, the answer is theta equals to 0. Yes?
Are we able to turn off this light?
Yeah, thanks. Yeah. Different. Yes.
How come we know it's the mean and not the max?
If I set theta equals to 180 and then I can compare them, I can tell you why it's going to be mean. But mathematically I can show you. But graphically you can see when theta equals to 0, this one is significantly less than this one when theta is 180. But mathematically I can tell you why it's going to be mean, why the other one is going to be nice. But you can see when the crank-rocker mechanism is running at theta equals to 0, this angle is smaller than this one. So meaning this one corresponding to the minimum and the other one should correspond to the maximum. So at theta equals to 180, just plug in theta equals to 180. Cosine of 180 is negative 1. So this 2ab is going to change to negative 2ab. Okay? So negative, negative, negative. I can write cosine of mu equals to b squared plus c squared minus a plus b squared. Okay? Yes.
Is you see that cosine minus all the way to the upper left?
This one,
Is there the bottom one continuing here?
2bc.
The one right at the bottom of it?
Okay.
Is that continuing from on top?
Yes, I just simplify these two.
Oh, you wrote there?
Yeah.
Oh,
And get differentiate that, differentiate both sides. Because I would like to find the extreme values. Suppose I ask you y equals to x squared plus 3x plus 5. Find the maximum value for this function. What you can do is differentiating y with respect to x and set it equals to 0. This is what you find the extreme values. I did it the same things here. Differentiate this from this one, dy over dx, d mu over d theta, set it equals to 0, and got the value that I can get for x derivative. Question? Any? All right, then mu max is gonna be cosine inverse d squared plus c squared minus 8 plus d squared divided by 2d. You can see for theta equals to 0, I plugged in theta equals to 0 in this equation and solve for mu, and we end up to this one. And for theta equals to 180, everything is the same except a minus d is going to change to a plus d. So, regarding to your question, if you compare these two, every term is the same except this one, these two. A minus d is smaller than a plus d. Okay, so smaller meaning the entire of this is going to be the larger number than this. So I have two angles. One is mu, I don't know it's max or min, and I have another one. But the cosine of this angle is larger than this one, meaning this guy is gonna be greater. Yes, smaller than this one, because the smaller angle we have, the larger cosine value. Cosine of, for example, 60 is 1.2. Cosine of 30 is 0.7. Yes, thank you. So it's greater than this, but 30 is less than 60. So I can say that minimum is mu for this and maximum is for graphically, I can get these two equations as well. This is the four-bar mechanism. Now I'm saying that when it goes to the 0 angle, I'm gonna get something like this. A, B, C, and D. So when theta is 0, I'm going to have this one. And this is the transmission angle of mu. I'm saying that it's a minimum value for the mu. So if I want to find mu mean in this triangle, I can write the cosine rule for this triangle. This length is B, this length is C, this length is D minus A. D minus A. So in this triangle, if I write the cosine rule for this angle, it's going to be D minus A squared, this length squared equals to B squared plus C squared minus 2BC cosine of mu mean. if you solve for mu mean, you will end up to this. You can see mu mean cosine of mu mean is gonna be b squared plus c squared minus b minus a squared divided by 2 is d minus a or a minus d, since both are squared, they are the same. Similarly, for when theta is 180, so a going in this way, a is this one, b is this one, c is this one, and d is this one. I'm looking for this angle, mu max. In this triangle, this length is b, this length is c, this entire length is d plus a. D plus a. Just change this negative to positive, and you will end up with the same result. Any question on this before we go to the class activity? So for a crank rocker mechanism, the extreme value of transmission angle occurring at theta equals to 0 and theta equals to 180. What will be the value of the transmission angle at extreme position? These two equations, those two equations, it's going to give us the response, and this is how we can get by drawing. Yes.
What would this also apply for a rocker? So what if the system can get to 0 or 1?
That's a class activity that you are supposed to work on that. What if we have what is the maximum and minimum transmission angle if you have double rocker?
So since I asked,
No, you think about that. I will answer if nobody could answer that. So if I move from crank rocker to double rocker, Grashof mechanism, double rocker. So what do you think about the extreme value of transmission angle? What you need to do, just think about the definition of the transmission angle. What is the transmission angle? And think about double rocker mechanism and see how that angle is varying when the mechanism is running. Number 34. Yeah. Oops. Why doesn't show that? What did I do? Okay, number 34. What do you think? I mean, I'm not necessarily looking for a correct answer. I just want to see how did you look at the problem? What do you think about the class activity? So if it's not the correct answer, that's fine. I mean, there is no. But I just want to see your you involved in the learning process. Go ahead.
I was thinking, well, okay, so our team over here, we're thinking 45 degrees for minimum max 135 degrees.
Okay, let me write it down. For so for mu mean is 45 and max is and how did you end up with this number?
Yes, really.
Okay, let me check the other. Number 27. Okay, and why is that?
Feels like a good fit.
Why it should be between 0 and 180?
So the minimum angle they can be between two links is 0 degrees.
Mm-hmm.
And then if they're straight apart, it'd be
180.
So that seems like the full range.
Any different thoughts? Yes.
So the maximum we got 180.
Uh-huh.
The minimum I got an expression for it.
Oh, okay, not 0. Just
Not
expression.
0.
Okay. Different idea. Let's look. Yes.
Just understand. What is the shortest link? The shortest link go around? Like, what is the shortest link go around?
Mm-hmm.
So,
It's where we have double rocker.
yeah, but is the
Go ahead.
translucent angle, is it always in the upper right of the actual mechanism?
Transmission angle is always between the output link, whatever is the output, either this one or this one,
Okay.
and the coupler. If this one is output, then transmission angle should be this. If I say the output link is this one, then transmission angle is gonna be this one. 0 and 180 is correct. Just look at when we have double rocker, ratio of double rocker, meaning this coupler complete 360 with respect to the yellow one or red one. So if it can complete 360 degree, it can see 0 and it can see 180. So 180 now, the maximum transmission angle, and it can see 0 as well when they both match.
I think we did the triple rocker.
Oh, okay. No, I asked double. We are still in ratio and double rocker. Triple rocker is the non-gray shock mechanism. That I'm gonna go over that. Any question on this? Next one is triple rocker or non-gray shock mechanism. Alright, when we have non-gray shock mechanism, meaning the three moving links are rocker. We don't have any links which can complete 360 degrees. We call it non-gray shock mechanism or triple rocker. Or we call it R. If this is the non-gray shock mechanism RRR, if you remember, I showed you the input link. I assume it's this one. Output link is gonna be this one. So transmission angle is gonna be this. So when we have non-gray shock mechanism, I showed you we are gonna have locking position when the coupler and the output they line up. We cannot go any further to the left side. So you should change the direction of motion from this link to this link and moving in this direction until you get another locking position between this guy and this one. So saying that when I'm at the locking position, the transmission angle is 180. This angle is 180 degrees. So mu max is 180. Now if I move to the another locking position, I will end up to this one, which is going to give me mu min. A, B, C, and D. If I ask you to find this angle, which is representing the minimum value of transmission angle, you can write the cosine rule for this triangle. Since these two line up, we have a triangle here. This length is A plus B, so I can write D square because it's opposite to mu min. It's going to be equals to A plus B square plus C square minus 2A plus B times C cosine of mu min. As solve for mu cosine of mu min. A plus B square plus C minus D square divided by 2A plus B times C. Any question about this? Locking position when output link and coupler line up. So this is the definition of locking position. This is locking position. We don't call this locking position, it's a toggle position. I'm going to define that, but still you cannot move any further. You have to change the direction of motion. But according to the definition, locking position happening when coupler and the output they line up. So I can ask you at which angle, at which input angle we are going to have locking position. So basically I'm looking for theta. At which input angle we are going to have locking position. You can write the cosine rule this time for theta. So it's going to be this thing b plus c square equals to a square plus d square minus 2ab cosine of theta, and solve for theta, cosine of theta. Cosine of theta would be a square plus d square minus b plus c square divided by 2a. Locking position. So you know that when your triple locker mechanism or non-ratio mechanism is at this input angle, you are gonna have locking position, the output and the coupler in line. Alright, let me define toggle position. When input link, not output, input link and output link line up.
Question.
Yes.
Shouldn't it be the input link and the coupler?
Coupler, sorry. Alright. Thank you. And coupler. Input link and output link, they have not been connected to each other. So look at this 4-bar crank rocker mechanism that we have. We learned that at theta equals to 0, we have mu mean. If it's moving right at this position, we can see input link and coupler, they line up. Why we are interested in toggle position? Because if you remember, mechanical advantage was defined as it's proportional to sine of this angle divided by sine of this angle. At this specific position, this angle is 180, sine of 180 is 0, we get high value for mechanical advantage. So mechanical advantage is proportional to sine of mu over sine of beta. And at toggle position, beta is 180. So if I ask you for this, for example, a slider crank, it's a slider crank. Find me at which angle we are gonna have toggle position. A, B, C, and D. I'm looking for T for toggle position. If if I ask you to find the theta at which I will get triangle position, again, we have a triangle because these two line up. We are looking for theta, so I'm writing the cosine rule for this thing. So c squared equals to a plus b squared plus d squared minus 2a plus b cosine of theta. And solve for cosine of theta. Good? You just see the different ways that I'm using the cosine rule to get different angles. So cosine of theta 2a plus b and b a plus b squared plus b squared minus c squared. This is the toggle position. Yes,
What is this, the
mechanical advantage.
approximately?
It's proportional, meaning if it's doubling, mechanical advantage is going to double. You remember that mechanical advantage was equals to the constant times sine of mu over sine of beta. So what I'm saying that if this ratio is increasing, mechanical advantage is increasing. If it's decreasing, this one is decreasing at the same.
Is it like torque?
Which one? Mechanical advantage? Mechanical advantage was the force that you get as output divided by the force that you apply to the mechanism. I think we did it on Wednesday or Monday class.
So the minimum mechanical advantage would be at the top of the position.
The maximum, because this angle is 180, sine of 180 is 0. So it's making this ratio a huge number. So it's one reason that we define toggle position, because toggle position is going to give us the higher mechanical advantage. So if you look at this 4-bar mechanism, this is a crank rocket. This is the toggle position. Input link is line up with the coupler, but let it go. At this specific position also, these two lined up. It's another toggle position based on the definition. The input link, which is the red one, is lined up with blue one. This angle is 0. The angle between these two are 0. Sine of 0, it's still a small value, or it's going to be 0. I will get the higher toggle position. I can ask you, what would be the theta for this toggle position? So it's going to be, it's happening at this position. We should write the cosine rule for this triangle.
You have 180 to the theta that you want,
180 minus. Because shouldn't theta be between the input and the ground?
Theta 2.
right? It will be,
Between the input
Yes, this 180 plus, thank you.
yeah.
plus should be minus, right?
If
Because we're coming this way.
we go through this way, we will find this angle.
It should be the smaller angle because it should be the same thing.
I mean, by writing the cosine rule, we will find this angle. Okay? If I subtract of 180, I will get this one. Because they are moving counterclockwise. This angle also is going to show me the other way.
Yeah.
But anyway, if I want to find this angle, the length of in this triangle, this is D, this is C, and this one is B minus A. The only difference between these two. B minus A. A plus B is minus infinity. Any question on this? Any question on this before we move on? All right. Let me take a look at the homeworks. From homework 3, you are gonna have at least 2 or more problems that you need to submit by using the MATLAB. So let me go for the rest of semester. We are gonna use MATLAB. As a version, this is acceptable to submit some of the homeworks problem. So let me look at. It's gonna be good practice, and it's gonna give you more skills on by writing the codes and working on this homework problem. So homework 3. This is gonna be 2 problems in this homework. Problem 415, only MATLAB code is acceptable. I created a Dropbox and Canvas. The due date is gonna be Thursday, next Thursday, at 11:59 p.m. So you can submit the homework before that time. After that, you cannot. And you can submit. For these 2 problems, you need to upload the M files and the Canvas.
All one canvas?
Yes, I have created a Dropbox over there. This one, homework 3 MATLAB file. If you go there, you can upload, and the due date for that is Thursday, 11:59 p.m. Yes.
Do you want 2 MATLAB files or just one that's been quotation?
I need MATLAB files. The team is gonna run that.
And so do you need 2, like, for each one or just one that
No,
shows?
this problem and this one. You are working on 1, 4, 5, and 6. Same as the regular homework. Just submit by paper. The hard copy. Problem 1, 4, 5, and 6 you submit on Thursday in the class as a hard copy with the paper. 2 and 3 should be submitted via the Canvas. Any question about this?
Can we combine the 2 MATLAB homeworks in one file?
No, don't do that.
So a separate file for each question.
For problem 2, and it's better that you name the M file like this. Homework 4, or 3. problem 1.
Okay.
Then if I read the title, I will see. All right, before we go, let me show you a couple of all right. On MATLAB, just I would like to just reference your time or recall something that you use in MATLAB. It's gonna help you on homework 3. If you use cosine, if you want to give the MATLAB an angle in degree, just type COSD. You're representing that the input angle is gonna be in degree. For example, 60, it's gonna be 0.5. But if you just enter COS 60, it assumes that this angle is in radian, which is not what we entered. So you will get a different answer. Another thing that I would like to show you is A cosine D. When you put A cosine, it's going to give you cosine inverse. If you are looking for theta, you need to find cosine inverse. So if you just put A behind that and use A cosine D, for example, 0.5. I would like to know which angle is going to have cosine equal to 0.5. I'm just typing A cosine D 0.5. It's going to give me 60. If you forget about D and type A cosine 0.5, it's going to give you the angle in radian. 60 degree in radian is going to be 1.047. So it's going to be the same for the sine. Sine degree of 30 is 0.5. A sine degree of 0.5. It's going to be 30. So, and if work on that, it's gonna, for the first homework, it's gonna take longer to finish up the M5, and make sure that the M5 is working. If there is a debug on the M5, the K is gonna give you 0. So don't submit the homework, the MATLAB files which are not working. All right, I will collect the homeworks, and I already posted the homework 3.